So, yes, last class we stopped at aromaticity. Remember?
Yes, ma'am.
So, we just quickly revise so that we are in the same page, that we can solve all the questions which shall be asked in the aromaticity. And I'll make you do tremendous number of examples, and you will not receive any other question apart from those examples. So my target is to make sure that I make you practice every compound which can be asked in your exam. So that will be my whole target. Okay. So while quickly realizing what is aromaticity, aromaticity is basically due to the nature of those compounds possessing aroma. And this came into the picture due to the fact C6H6. So C6H6, I know C double bond C and C double bond C. That is the two types of bond which is available. You want to shift to this side? I think that would be better. So I have two types of bond. So that means one is a single bond. Single bond is supposed to be around 158 picometer, and the double bond is supposed to be around 132 or 128. That's the range of it, right? That is the range of it. But in the case of C6H6, it was found that every carbon bond which is present over here ranges. Let it be single bond, let it be double bond. It ranges around 138 picometer. Okay. So why is this happening? So what conclusion came into the mind? That all the CC bonds are together in one phase only. There is no difference between a double bond and a single bond. So that is why the resonance we speak about. When we speak about the resonance, that's why the resonance came into the picture, stating that all the bonds are equivalent in bond length. Right? This was the whole concept. Now when I talk about my aromaticity, so let's say aromatic compound. Last time when we spoke about it, aromatic compounds are those compounds which has a cyclic structure, a closed ring structure. I can also put it like that, a closed ring structure, as well as it should be a planar molecule. It should be a planar molecule. Apart from that, one more point which it has to satisfy is it should have a conjugated pi electron system. And last but not the least, it should follow Huckels rule. What is Huckels rule, Ankit?
The number of pi electrons must be equal to 4n plus 2.
4n plus 2 pi electrons, and where n is the whole numbers, 0, 1, 2 and so on, right? These were the four conditions for a compound to be aromatic. Now Sheetal over here says that I do not understand how do I determine conjugate pi electron system in a given molecule. So let's do it by an example. Let's say I have been given this compound, cyclopentadiene. Okay, so in this compound, is this the cyclic structure?
Yes, ma'am.
It is, because it is consisting of a closed ring. Now, when I come to the planar molecule, is it a planar molecule?
Yes, ma'am.
It is a planar molecule. Okay. What is the hybridization of this carbon, this carbon, this carbon, this carbon and this carbon? Can you quickly determine what is the hybridization of each carbon over here? So this is how it is. Basically, H H, H, H and H2. Can you quickly determine the hybridization of every carbon, carbon 1 to 5? sp2 of which one? Which carbon? So 1, 2, 3, 4, 5. I have 5 carbons. So how many carbons are sp2? Or which carbons are sp2? You are mentioning it. Reshma, do you want to say something to it? What all carbons will be which hybridization? Okay, so she's writing C1 is sp2. Do you all agree C1 is sp2?
No, ma'am. It is sp3.
Yes, it is. So see how many bond does it has? I drawn the open structure as well, right? 1, 2 and 2 hydrogen. So that means how many bond does it has? It has 4. So that means it is sp3 hybridized. So the carbon number 1 is sp3. What about carbon number 2, 3, 4, 5?
They are all sp2.
sp2. They all are sp2. Reshma, is it clear why that one is sp3? So now when I talk about a planarity of a molecule, I know sp2 is a trigonal planar, so all the bonds exist in the same plane. But as soon as I encounter an sp3 carbon, that means the compound or the molecule is not a planar molecule. So that means it does not satisfy the second condition, that planarity is missing. As well as the conjugated pi electron system is also missing. So if you see, this is what you got. This is your pi bond. This is your pi bond. This is your sigma bond. Sigma bond again. Then pi. So in order to have a conjugated system, remember you should have sigma pi, or else sigma lone pair, pi, sigma lone pair. So it should be that order. If at all 2 sigmas are coming together, so understand that that does not have a conjugated pi electron system. That is how you are supposed to judge it. So this compound becomes non-aromatic. So let's say I give you another example, which is, let's say, I have a negative charge over here. Now, what kind of compound is this? Aromatic, anti-aromatic, non-aromatic. 3 classes we have studied. So, what will be this? Does it has a cyclic system?
Yes, ma'am.
Everybody
Yes,
agrees it has a cyclic system?
Yes, ma'am.
What about the planarity?
Yes, ma'am.
It is planar in nature. What about conjugated pi electron?
Yes, ma'am.
So if I see conjugated pi electron, this is sigma, this is pi, this is sigma. Again, this is your lone pair, right? So this lone pair, then sigma, then pi. So that means it is conjugated. So that's why this is conjugated. And does it follow Huckels rule? 4n plus 2 is equal to 1, 2, 3, 4, 5, 6. So that means 6, n comes out to be 1. So this compound is aromatic in nature. Anybody has a doubt in determining how do I determine the aromatic nature? No, right?
How do you calculate it? 6 other like a bond?
So you need to see the number of pi electrons. You need, so it is 4n plus, if you see the Huckels rule, it says 4n plus pi, 4n plus 2 pi electrons. Okay, so pi electrons over here 1, 2, 3, 4. And this lone pair is also involved in the conjugation, so we will consider that also in the pi electron system. So that is why 6. 1, 2, 3, 4, 5, 6. So this is what it looks like. Clear? what were the conditions for anti-aromatic and non-aromatic?
Anti-aromatic, it follows 3, but not Huckels rule.
Yes. And in the non-aromatic,
It does not follow cyclic planar.
or any one of them. So, anti-aromatic, the first 3 rules, cyclic, conjugated, and your planarity is followed. But Huckels rule is not followed. Huckels rule is not followed. Whereas in the non-aromatic, either 1, 2, 3, the 1, 2, 3 condition, that is cyclic, planarity or conjugated, any one of them, 2 of them or 3 of them, if anything is not followed, then this Huckels rule really doesn't matter in this case. Huckels rule doesn't matter when any one of those conditions is not met. So Huckels rule does not matter over here. In that case, that kind of compound will be non-aromatic if either one of them is not followed. Either one of them is not followed. So I can have n number of examples for this. Any aliphatic chain you take it, that falls under non-aromatic. Any ring structure which does not have a conjugated pi system, that falls under non-aromatic. So I can have n number of examples for non-aromatic. Is it clear? So the only point I need to remember is anti-aromatic and aromatic. So that is where the main difference arises over here. Okay. So there are another class of compound referred as heterocycles. Have you heard about them? Heterocycles. Anybody from the online group who can tell me what are heterocycles?
Ma'am, those who are saturated.
Those who are saturated. Okay. Can you elaborate a little?
Like cyclohexane.
Okay, cyclohexane is heterocycle, you are saying. So this is your cyclohexane and you are saying this is heterocycle. And this is your aromatic. That is what you are trying to tell me?
Yes, ma'am.
Anybody else who has a difference in opinion about heterocycles? What about the rest of the group? Everybody agrees with this thing? Okay, what will be the kind of compound if I introduce an extra element into the ring? What will be this called as? Ankit? What kind of compound will be the ones in which there is a nitrogen, fluorine or a sulfur present? What kind of compound will that be?
Non-aromatic.
No. I'm not talking in terms of aromatic or non-aromatic. I'm talking in terms of there will be class of compound they're named under, right? What will be they named under? Like you mentioned, cyclohexane falls under heterocycle. I am asking what will be the falling for this one?
Now, ma'am, these are following heterocycles.
Yes. Ankit? Do you agree?
Yes, ma'am.
Do you agree?
Yes, ma'am.
So heterocycles are not this. Heterocycles are this, the one which contain extra elements. Extra elements are what are extra elements? Nitrogen, sulfur, oxygen. These are extra elements, and when they are contained in the ring form, they are referred as heterocycles. Okay. Now let's talk about aromaticity of these compounds. So let's say I have been given pyridine. This compound is referred as pyridine. Okay. So I want to talk about its aromaticity. What can I say about its aromaticity? Anyone? Will it be an aromatic compound or non-aromatic or anti-aromatic? What do you think?
It will be aromatic.
Non-aromatic.
Okay. So Ankit is saying non-aromatic and Sheetal is saying it is aromatic. Okay. Anybody else? Reshma is also saying it is aromatic. Reshma is also supporting the aromaticity. Ankit, why are you saying it is non-aromatic?
Ma'am, it is not planar.
It is not planar. Okay, fine. When you are saying it is not planar, how it is not planar? Let's just try to understand that. So it is a cyclic system. It is very well away from the ring. It is a conjugated pi electron system. That is also very well. You can see it is sigma and pi electrons are alternating. Now we are talking about planarity. When I am talking about planarity, I am supposed to determine every carbon and the nitrogen hybridization. What will be the hybridization in each case? sp2, every carbon. And what will be the nitrogen hybridization? Nitrogen hybridization. Ankit? Reshma? Avni? Anybody? What will be the nitrogen hybridization? We have done hybridization chemical bonding chapter. How many bonds and how many lone pairs? 2 lone pair, 1 lone pair. Lone pair is always present in a pair. So 1 lone pair. So that means 1 lone pair. Abhi is saying. Okay, so what will be the hybridization of nitrogen over here? sp3. Perfect. But what I am trying to tell you over here is, this is a planar molecule. This is a planar molecule. Let's see how it is a planar molecule. So you know the pi system are above and below for the double bond in every carbon, where it forms the double bond. So in fact, even in this, it forms a double bond, right? You can see it forms a double bond with an sp2, right? So it cannot be forming a double bond within a carbon which is out of the plane. So there comes the exception cases of the compound. So the heterocycles are the exception case of the compound, stating that they all are planar in nature. They exist an exception. So we spoke about sp3, okay fine, it is not a planar thing. So far when the carbon-carbon thing arrived, we were perfectly fine. Now as soon as in a heterocycle, that is a nitrogen containing compound or an oxygen containing compound or a sulfur containing compound will come into the picture, hybridization might be sp3, but they all fall under the category of planarity if they form a double bond. Fine? One thing is clear? Is it clear?
Yes, ma'am.
So what can I say in this manner? It is a planar molecule.
Yes, ma'am.
Does it has a does it follow the Huckels rule? Now my question arises, does it follow the Huckels rule? Will this lone pair contribute to the conjugated part? Will this lone pair will be conjugated? So let's try to imagine this. So what is happening is, I have pi. So this is your pi system, sigma, pi, sigma, pi, sigma. Were these lone pair involved anywhere? No.
No.
So I won't be counting them for the 4n plus pi electron rule. So how many pi electron? 3 sets.
3 sets.
So that means 6 electron. So your n becomes equals to 1. Thus this compound is aromatic in nature. Clear?
Yes, ma'am.
What about the rest of you guys? Clear?
Yes, ma'am.
Fine. Very well. So let's see another example. Pyrrole. What happens in the case of pyrrole? Let's see. Is it cyclic?
Yes, ma'am.
Does it has planarity? That's the question
Yes,
mark. And does it has a conjugated pi-electron system? So if I see sigma, pi, sigma, and I will consider their lone pair. Yes? Somebody was saying something? So lone pair, sigma, pi. That means it is a conjugated pi-electron system. Now we come to the planarity. If you see over here as well, it is sp3. It is what do you call 1, 2, 3. 1, 2. It is sp2 hybridized. So it is a planar in structure. So it is planar. Now let's see the Huckels rule, whether it is following or not. So that means, is it following the Huckels rule? No. How many electrons? Pi electrons. How many pi electrons, Reshma? Plus 2, yeah. Shanmuka and who else? I have one new member.
Ma'am, it is following.
Shanmuri. Are you following? I think I've seen you for the class for the first time. So it has 6 pi electron. So n becomes equals to 1. Thus this compound is also aromatic. What about furan? So I give you another example. This is furan, referred as furan. What happens in the case of furan?
It is following cycle.
What happens in the case of furan?
It may be anti-aromatic.
It may be anti-aromatic. Anybody else? So Sheetal is saying it is anti-aromatic. What about rest of you?
Aromatic.
Okay. Ankit is saying aromatic. What about
Aromatic.
Okay, aromatic. Can you explain why aromatic? And can you help Sheetal, your colleague, why it is aromatic, why it is not anti-aromatic? First, let's just understand why Sheetal is saying anti-aromatic. Why are you saying it is anti-aromatic?
Now maybe it does not follow the Huckels rule.
Maybe you have to tell me what is the reason for your thinking that it is anti-aromatic. What is the reason? It's okay.
Ma'am, it is following cyclic.
Okay, it is, as per her, it is cyclic, fine, perfect.
It is also following planar.
Okay, it is following the planarity as well. And does it have a conjugated bi-electron? So how many lone pairs are there on the oxygen? 2 set of lone pairs are present. Will both of them be involved in conjugation or only one set? When the conjugation is occurring, will both of them will be involved in the conjugation or only one?
set.
Only one set. So that means one set. So sigma, pi, sigma, lone pair, sigma, pi. So conjugated system is there. Huckels rule. 4n plus 2. How many pi electron, Ankit?
6.
6. Why 6? Because I have considered this lone pair as well. Why is it happening again? So 6 pi electron, that means n equals to 1, thus this is also aromatic. Clear? Okay. Let me modify this structure. How will I modify this structure? Let's say this is the compound given to you. Everybody can see the compound? Now you need to tell me whether it is aromatic, non-aromatic or anti-aromatic. Everyone quickly.
Non-aromatic.
Non-aromatic. Anybody else who think it could be something else apart from non-aromatic? Everybody agree? Why do you say that, Ankit? It is non-aromatic?
Ma'am, 1 carbon is sp3.
2 carbons are sp3.
2 carbons.
Yes. And it does not have conjugated pi electron as well, which makes this compound non-aromatic. So let's say I'll give you another example. Positive charge, positive charge. I'll give it more examples. So I have given you 6 compounds. One we have already done. So 6 compounds. You need to tell me each one of them, which one is aromatic and which one is non-aromatic or which one is anti-aromatic. Do it, work it out, everyone, and then give me the final answer for each one of them. Mark it as B, C, D, E, F, G. And anybody in the online group who isn't following, please tell me right now so that I can make you understand how are we arriving at this. If anybody has any doubt, please speak up. Because this will be the last class for your aromaticity. And I want you all to be perfect in the aromaticity. That you do not lose out marks on this. And one question generally do come. And what type of question arises, that will also I will discuss. Are you doing it? post your answer on the chat box, please. He is aromatic. Okay. Reshma, Agni, Shanmuka, what are your answers for the B part? Ankit has already given me mark. What is
Aromatic.
Okay, Sheetal is as well saying aromatic. What about you guys? Shanmuka is also saying aromatic. Agni, Reshma. B is non-aromatic. Okay. And Reshma is also saying that. Who else is left? Agni, what about you? Okay, let's see. Is it a cyclic structure? Yes. Is it a conjugated structure?
Yes, ma'am.
Okay. Is it a planar structure? Yes. sp2, 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 sp2.
Yes, ma'am.
It is a planar structure. Does it follow Huckels'
Yes,
rule?
ma'am.
4n plus 2 is equal to 2. So n becomes equals to 0. So that means yes. This is an aromatic compound. Reshma, did you understand? Which factor did you rule out for non-aromatic? Conjugated system. Okay. So if you see over here, this is pi, sigma, charge is there. So that can conjugate. Then comes your sigma again, charge again. And then comes your sigma, then pi. So this is a conjugated system. Clear? Fine. C part. What is the answer for the C part?
It's non-aromatic.
Okay, this is non-aromatic. Sheetal suggests. What about rest of you? Ankit is as well. Why do you say, Sheetal, it is non-aromatic?
Because, ma'am, it is not following the sp2 all.
So that means even the planarity and conjugated system, both are not followed. That's why it is non-aromatic. Clear? What about D part?
Anti-aromatic.
Anti-aromatic. Okay. What about any other person with any other answer? Sheetal, what about you?
No, I'm confused with the negative charge, how I will consider it. So that's why I didn't take it.
So anything. So
Yes, ma'am, it may be anti-aromatic.
okay, it is anti-aromatic. Reshma is also saying anti-aromatic. I am saying it is non-aromatic. This is wrong. This is right.
And I write non-aromatic.
So non-aromatic, why it is? Cyclic structure, perfect. It did not follow the conjugated system. So see, pi, sigma, lone pair, sigma, and then there is nothing. Again a sigma is coming, sigma, sigma. So that means conjugated system anyway is not there. And you could have actually very well guessed it, this was sp3 hybridized in the case of carbon. There is no heterocycle over here.
Yes, ma'am.
So anyway it lost its planarity as well.
So it is non-aromatic.
So that is why it is These two things are not followed. That's why it is non-aromatic. Anti-aromatic it would have been when it would have followed the all three. Huckels rule it is not following. It's very well understandable. Is it clear?
Yes, ma'am.
Why it is not anti-aromatic? Okay. Then what about the E part?
It is non-aromatic.
It is aromatic you're saying. Okay, Sheetal is giving aromatic. What about rest of you?
Anti-aromatic.
Okay. Ankit is saying anti. Only one option left. Does anybody has that option also on the mind? Reshma is saying aromatic as well. Okay. Ankit, what Huckels rule is not followed? According to you, that means?
Ma'am, only one lone pair can be considered as pi electron.
No. That is where we are wrong. It is not like that. So see, it is pi, sigma, lone pair, sigma, lone pair, sigma. So this is a conjugated system in which both the charge can be involved.
Yes, ma'am.
One lone pair on one atom can be considered. That is what we did in the case of furan. Remember, it was present at one particular position. Both the lone pairs were present. At that time, we considered only one of them because only one would be involved at one time. But here they are present on two separate carbons. That is why this is an aromatic system, not anti-aromatic. Cyclic, conjugated, planar, and 4n plus 2 is equal to 6 pi electrons. Clear, Ankit? Still
Yes,
has a
ma'am.
doubt? Okay. F part, F and G. The only difference is one has a positive charge, one has a negative charge. So what it will be?
F is aromatic.
F is aromatic. And what about G?
G is also aromatic.
G is also aromatic. Sheetal is saying. Anybody else? F.
Ma'am, G is anti-aromatic.
G is anti-aromatic. Okay. Sheetal, could you explain why this is aromatic?
Because ma'am, it is following the cyclic
Hmm.
as well as conjugate.
So that means
So that
it is a
is
cyclic, it is conjugated, it has a planarity as well, and it follows Huckels rule, that is 2 pi electrons. Right? In this case, it is anti-aromatic, not aromatic. Why it is so? Cyclic, conjugated, planar, but 4 pi electron. So your n becomes equals to half, which is not possible. Huckels rule is not followed. That is why it is anti-aromatic. Clear? Let's do more examples. Start doing it. Don't wait for me. I'm drawing the structure in the meanwhile. Six compounds are present on your board and you need to tell me what are these compounds classified as? First one done. Okay, Ankit is saying non-aromatic. Reshma is also saying non-aromatic. Shanmuka and Ammi.
Non-aromatic, ma'am.
Non-aromatic. So everybody agrees non-aromatic. Why it is non-aromatic? Due to the losing the planarity. Planarity is not followed in the case of this. What about the second one?
Non-aromatic.
Non-aromatic. Same way, planarity is not followed over here, as well as conjugation is also not followed over here. Right? What about the third one?
Non-aromatic. Non-aromatic.
Non-aromatic. What about this? This compound is referred as thiokene. This is a different type of an example. What would happen in this case?
It is non-aromatic.
Aromatic.
I did not hear you. Aromatic or non-aromatic?
Aromatic.
Aromatic. Everyone agrees aromatic? How it is aromatic? Because sulfur also has two set of electron, and just like oxygen, only one set will be considered, and it is cyclic, it is planar, it is conjugated, and Huckels rule is 4n plus 2, which is equal to 6 pi electron, n is equal to 1, thus aromatic in nature. Clear? What about the fifth part?
Anti-aromatic.
Anti-aromatic. Because the first three rule is followed over here, whereas the 4n plus 2, if I see the 4n plus 2 rule, it would be 4 pi electrons only, thus n is half. So, no, anti-aromatic. Huckels rule is not followed. What about sixth one?
Anti-aromatic.
Anti-aromatic again, because again it becomes, instead of 4 pi electron, it becomes 8 pi electrons. So which case would have been actually aromatic? If there would have been one positive charge and one negative charge. Would this be aromatic?
This one.
Everybody agrees?
Yes, ma'am.
Yes. So now I arrive at the conclusion that what type of questions are generally asked in this. One is a straightforward question. The compound is given to you just like these many examples, and you have four options are given: aromatic, non-aromatic, anti-aromatic, none of these. Okay, this is one set of type of example which can arrive. Another set is that compare the stability. So when I am comparing the stability, so understand aromatic compound will be more stable. Then non-aromatic. Then anti-aromatic.
Anti-aromatic, the 3-1 it follows, so
But still, so the stability order for that matter. Aromatic, I'm very well clear, it tries to retain the aromaticity, so it's very good. When I talk about non-aromatic, most of the compound in nature are non-aromatic in nature. If it hadn't been stable, then it wouldn't have existed. Anti-aromatic, it has a tendency to go to the aromaticity very easily. So, but it is not stable. So what it will try, as soon as you have an anti-aromatic compound, it will try to do something with the electrons so that it can reach the aromaticity. Clear?
Yes, ma'am.
So, let's say I have been given, you have already calculated, these 3 compounds are given A, B and C. I am telling you to arrange them in increasing stability. How will I do that? I want you to arrange them in increasing stability A, B and C. 3 parts are given to you.
CBA.
So,
CB.
C, B and A.
A.
Everybody is getting the same answer?
Yes, ma'am.
Okay. C is anti-aromatic in nature.
Yes, ma'am.
B is non-aromatic. And your A is aromatic in nature. So what is the other way round of asking this question? What is the other way round? 4 compounds will be given to you. Find out which one is stable. Just a minute. So, what can be the other type of framing the same question? Which out of these is least stable? And your options are these are your options. And you need to tell me which out of these is least stable.
A.
Yes, ma'am.
Why A?
It is anti-aromatic.
Aromatic, and this one is.
So, this is anti-aromatic, this is your aromatic, this is aromatic, this is aromatic. So, the least stable would be the one which is anti-aromatic. Perfect? So, this is the kind of questions expected. Now, there comes another different type of class of compounds. Sometimes that also is being asked. So, let's say I am drawing all of them and you have to tell me whether it is aromatic or non-aromatic or anti-aromatic. These many for the time being. What will be the answer for the first one? It's a 3-membered ring. Is it that way? What will be the answer for A1? A part?
Aromatic.
Aromatic. What about others? Let me change it. Did I change it?
Aromatic. Yes, ma'am, it is aromatic because I didn't.
What about rest of you guys? Aromatic or non-aromatic or anti-aromatic? Okay, Reshma is also saying it is aromatic. Okay, why do you say that it's aromatic? Can anyone explain? Can anyone?
Ma'am, it is planar.
It is planar, okay. It is cyclic anyways, which is visible. Does it have a conjugated system?
Yes, ma'am.
How it will be? So, in order to see the conjugated system, I'll be rearranging it. How can I rearrange it? By making this double bond carry. As oxygen is electronegative, will pull the electron towards itself, thus resulting in a positive charge in the ring. When there is a positive charge, so that means it is cyclic, it is planar, and it is conjugated as well. And it follows 4n plus pi electron rule, where n is equal to 0, right? So that is why this compound is aromatic. Clear? What about the second one? Anti-aromatic. Sheetal is saying anti-aromatic. What about rest of you? B?
Non-aromatic.
Non-aromatic. Reshma? Shanmuka? Avni?
Non-aromatic.
Non-aromatic. It will be non-aromatic. This carbon over here is sp3 hybridized, which makes it lose its planarity. Thus, non-aromatic in nature. What about this C part? The only difference between the B and the C part is the carrying positive charge. Now what would happen to this compound? It is a 7-membered ring. Everyone understand that, right?
Aromatic.
So this is aromatic because it follows the Huckels rule, where n will become equal to 1. What about D?
Anti-aromatic.
Anti-aromatic, because 8 pi electron system it would be. So that's why it is anti-aromatic. Now E is a very interesting example. Let me draw it in the next page. E part. And I want everyone's answer on this, and why do you think so?
I think it is non-aromatic.
You think it is non-aromatic. Sheetal is saying it is non-aromatic. What about rest of you guys? It's okay. See, you might have
Ma'am,
thought.
I think it is aromatic.
Okay, so aromatic I have one contender and non-aromatic I have one contender. What about rest of you guys? Let's see who wins. Reshma?
Ma'am, anti-aromatic.
Anti-aromatic. Okay, I got another one. Anti-aromatic. Shanmuka, Avni. Where do you agree? Aromatic, non-aromatic, anti-aromatic? I'm not getting an answer. So you have to break the tie, right? Right now I have a tie between all three of them. They are responding. So, in order to understand whether it's aromatic or anti-aromatic or non-aromatic, so similarly, the oxygen will pull the electron over here. When it is pulling the electron, see what happens. This carries a negative charge, this carries a positive charge, and oxygen is present over here with the double bond. Clear? Now, that means pi, sigma, and this positive charge, then sigma, oxygen has a lone pair, and then sigma. So it has a conjugated system, plus its planar molecule, and it is cyclic in nature. Now comes the question whether it follows Huckels rule or not. While following Huckels rule, 2 pi electron, 2, and here 2. So that means 6. So 6 pi electrons, that means N becomes equals to 1. So thus this compound is aromatic in nature. Who gave the answer aromatic? So this is an aromatic compound. Anybody has a doubt in understanding why this compound is aromatic? Ankit, Reshma, for you that matter. So whenever there is something like this system is given to you, so like we did 2 examples of this. One was double bonded O like this. Another one we did it, which was like this. So in this case, I pulled those double bond towards the more electronegative atom, resulting in a positive charge on the ring. Okay, remember it. So as such, this compound I will not be able to judge. But if I make the chemical structure, the resonating structures of this, then only I can conclude whether it's aromatic or non-aromatic or anti-aromatic. Clear?
Yes, ma'am.
Now comes another system consisting of various benzene rings. So what kind of various benzene ring? So one such great example is naphthalene. Have you all heard about naphthalene? What is it basically used in? Where does you use naphthalene?
For the cloth.
Yes, to protect our clothes from moth and everything, the insects which grew up when you keep it in the cupboard. So the smell does not let. So these are very vaporizing in nature. So I tell you one great example. So what happened during my graduation final exam, I got this compound to identify. So there you need to identify the given organic compound. So that's the series of tests you need to perform. You need to find out which functional group is present and what called extra elements. So what are extra elements? Nitrogen, sulfur, and your halogens. So I need to determine. So this compound gave nothing because this has no extra element, no functional group, nothing at all. All I had was the melting point and it is unsaturated. I was so irritated that it was a final exam and I could not find out, like, it has no functional group, where will I relate it to? So then somebody suggested, smell it. You will find that smell very familiar. So when I smelled it, I was like, yes, I have smelled this thing. So that is how I concluded, okay, naphthalene it could be. So this is how you actually, so when you perform the experiment, even in the labs you might have performed identifying the functional group. So in that case, that is how the series of steps. So this naphthalene is an aromatic compound. I am saying this naphthalene is an aromatic compound. Do you all agree or do you all disagree?
Agree, ma'am.
You agree? Okay. So I can see it is a cyclic system.
Yes, ma'am.
I can see it has conjugated pi electron. Does it has conjugated pi electron? This bond is common between the both the, right? So conjugated pi electron, and conjugated pi electron will be seen as a whole,
Yes, ma'am.
not as an individual ring. Okay? If I take it as individual ring, then this doesn't become what you call aromatic. So you need to consider it as a whole. Fine. It is a planar structure. Thus, and 4n plus 2 electron becomes equals to 1, 2, 3, 4, 5. That means 10 electrons. Right? So your n comes out to be, what does n comes out to be? 2. Clear? So I can have one more example based on this, which is referred by the name anthracene, which is 3 benzene ring fused together, referred as anthracene. What kind of compound will this be? Anthracene. Anyone?
Aromatic.
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 Aromatic. What about you, Sheetal?
Ma'am, it will say that this was a bond to another.
Yes.
So then it is aromatic.
So it is also aromatic because all 3 rules are followed, and I need to see whether it follows the Huckels rule. 4n plus 2 is equal to 1, 2, 3, 4, 5, 6, 7. 7, that means 14 electron. So my n comes out to be 3. Clear?
Yes, ma'am.
So this anthracene has an isomer like this as well. This kind of compound, this is isomer. Okay, either one of them, they both are aromatic in nature. So these were fused rings. Fused ring where 2 bonds, where this 2 carbon are fused with another ring. So there comes another class of compound which are referred by the name biphenyls. Biphenyls looks like this. Now, what do you expect these class of compound to be? Aromatic, non-aromatic and anti-aromatic.
Anti-aromatic.
Okay. Everyone agrees with anti-aromatic? Why do you say that it is anti-aromatic?
Because ma'am, it will not follow the Huckels rule.
Huckels rule. So everyone saying Huckels rule is not followed. Right? But I am saying this compound is not anti-aromatic, it is aromatic in nature. Now comes the another exception. Oh, why this is not clear? So I am saying this compound is aromatic. So when I consider biphenyls, so how did you get it anti-aromatic? Because 4n plus 2 is equal to 1, 2, 3, 4, 5, 6. So that means 12 electrons, where thus n is equal to becomes 10 upon 4, which is 5 by 2, which makes it anti-aromatic. But what is the exception followed in biphenyls? The exception followed in biphenyls is that we consider individual rings. There we did not consider them as an individual ring, but the biphenyl, that is when connected to one carbon, then we consider individually. If the individual rings are aromatic, then the compound is aromatic. So individually, are these rings aromatic?
This one.
Yes? Everybody agrees? So,
Yes, ma'am.
so this is an aromatic compound. So let's say, for example's sake, I give you this as an example. Now, is this compound is aromatic?
Ma'am, it is non-aromatic.
It is non-aromatic because one ring is following aromaticity, the other ring is non-aromatic, thus making the whole molecule non-aromatic. So far what all we have seen? We have seen compounds containing extra element, but we saw only one ring structure. What if I fuse
This you said that one is aromatic and another is non-aromatic.
thus making it whole compound non-aromatic?
Okay. So
Somebody has unmuted. Ankit, can you mute yourself? I'm receiving lot of disturbance. Yeah.
Ma'am, I am muted already.
Okay, so Avni, can you mute yourself please? Otherwise, do you have anything to say?
but why we are only considering non-aromatic, not aromatic?
Because whole compound will be considered, right? Just a part of the ring won't be considered. Part of the ring, if I am considering, then it is aromatic. But as a whole, when a compound is being asked whether this organic compound is aromatic, anti-aromatic or non-aromatic, I'll be considering the whole compound.
Then if there will be a exception मान लेना biphenyl में इसके साथ एक और joint कर दिया जाए जो कि anti aromatic हो.
इसके साथ एंटी एरोमेटिक, चलो वो कंडीशन आएगी नहीं, but let's say what you are trying to tell me is
One is aromatic, another is non-aromatic.
3 rings
Yes,
biphenyls. When I'm talking about biphenyls, it's only one. Two. Okay. So I can have another ring which is anti-aromatic. So let's say this I have it. This is aromatic. This is anti-aromatic. Thus the resultant compound becomes anti-aromatic. Fine?
This one not.
Everybody is clear about this thing? What she was asking, what if instead of non-aromatic I have anti-aromatic? Then will that compound becomes anti-aromatic as a whole? Yes, that compound will become anti-aromatic as a whole. Clear?
Yes, ma'am.
So now comes another class of compound. Now we did, if you remember in the heterocycle, I did 3 compounds, that is thiophene, I did pyrrole, I did furan, and I did pyridine. Right? These were the 4 compounds I did. I can now fuse this ring with benzene ring. Let's see what happens. So let's say I have fused this ring with benzene ring. So this becomes indole. Its name is indole. Now whether this compound will be aromatic, anti-aromatic or non-aromatic? What do you expect?
Non-aromatic.
Aromatic. Okay. Anybody else?
Aromatic.
Okay. Reshma, have you posted it yet? Yes, you are also saying aromatic. Avni, Shanmuka, what about you guys? Okay. Now, can you tell me, Sheetal, why it is aromatic?
Because ma'am, the bond which is it will be share this, then this is also aromatic and this is.
Nah, that's where you went wrong. In the case of biphenyl, I mentioned I'll consider two individual rings as an individual ring, two rings as individual. But in the case of, if you remember when we did naphthalene, did I consider them as two different rings? I considered that as one,
Yes ma'am.
and I calculated the Huckels rule.
Yes ma'am.
So, same thing will be followed. When fused with two carbons with the ring, then you are considering the whole compound. But when it is a biphenyl, that it is fused with one carbon, then you are considering individually. So, based on that, what will be the answer for this?
Anti-aromatic.
Yes ma'am. Then it should be anti.
Okay, anti. Reshma, do you agree or do you still sticking to aromatic? Okay, she's also saying anti-aromatic. I'm saying aromatic.
Ma'am, aromatic. Ma'am, aromatic.
Yes, it is aromatic. How it is aromatic? Now explain.
Ma'am, lone pair of nitrogen.
Yes, you will not forget the lone pair on the nitrogen, and thus this becomes how many electron system? 10 pi electron system, thus making it aromatic. Clear?
Yes ma'am.
Shanmuga and Reshma, who pointed out anti-aromatic, planarity, conjugated pi electron system and cyclic. These three rules are followed. But what is the only difference which I am just going to encounter is the, if I do not if I do not account for the nitrogen lone pair, then it becomes anti-aromatic. But when I account for the lone pair on the nitrogen, then it becomes aromatic. So I will account for the aromaticity with the help of your lone pair. Clear?
Yes ma'am.
I can have another example. Ta-da! What would happen to this?
It will also aromatic.
Okay, aromatic, she's saying. What about rest of you guys?
Aromatic.
Aromatic. Reshma, Shanmuga, Avni.
Aromatic.
Aromatic. Similar example.
One set of protein.
Only one set of lone pair will be considered for accounting for the Huckels rule, thus 10 pi electrons, right, resulting in n value to be 2. Clear? Okay. Let's see what happens now. Let's say I have been given with this.
Aromatic.
Again aromatic.
Same condition?
Aromatic.
Same condition? Now let's see what I'm going to do with this. I am going to modify this is pyrimidine ring. In the biology, if you would have done DNA structure, pyrimidine and purines, that makes up for DNA, right? So this is your pyrimidine ring. What happens in this? Whether it is aromatic, non-aromatic or anti-aromatic.
It is also aromatic.
Non-aromatic.
Aromatic, okay. What about rest? Everybody is agreeing with aromaticity?
Non-aromatic. Non-aromatic.
Oh, I'm sorry. Okay, Reshma is saying aromatic and rest of you are saying non-aromatic. Okay. Reshma, why do you say it aromatic? You guessed it, so it cannot be a fluke. You might have thought about
because
it.
the nitrogen will also share their.
Okay, there are two set of nitrogen.
So one will be shared.
One if so let's say this and this. One if you are sharing it, how many total number of electrons you are coming as? 12 pi electrons. So 12 pi electron, does it follows Huckels rule? No, it does not follows Huckels rule. Your answer is right, but your rationale is wrong. And you guys, why do you say that non-aromatic? Because of the 12 pi electron, right?
Ma'am, we will consider only one set of.
Exactly. So if you remember, in the case of pyridine, the lone pair present on the pyridine were not considered while accounting for Huckels rule. Here only 6 pi electrons were considered. In the similar manner, this nitrogen lone pair will be considered. So when I see the sigma pi, sigma lone pair, sigma, so that is how the cycle goes. Pi, sigma, sigma, sigma. So this is how the circle goes. So when the circle goes like this, so that means only 10 pi electrons, making this compound aromatic, not non-aromatic. And you guys said it non-aromatic or anti-aromatic?
Ma'am, I let the lone pair as charge. So ma'am, minus and pi, so I thought to be non-aromatic.
That is fine. See, this is the common mistake, everybody does it. Why am I taking so many examples? Because everybody, so maybe not you, somebody else might be doing the same mistake. So we can learn from the other people's mistake as well. So remember it. So my purpose of making you solve all these questions is this only. Okay, let's see another example. What do you expect?
Aromatic.
Aromatic. Sheetal, what about you? Reshma, what about you? Reshma, is it a non-aromatic? No, this is the previous answer, I suppose. Okay, aromatic. What is your answer? Anti-aromatic. Okay, anti-aromatic. So I got two options. Aromatic is the right answer. The lone pair on the nitrogen will not be considered. So we need to understand when to incorporate and when not to incorporate. Okay, so what I have seen so far, what trend has been followed. So though if that extra element is involved in formation of a double bond, then the lone pair is not considered. Whereas when it was present as it is with the double bond, okay, double bond, this will be the complete structure. When it is not involved with the double bond, then the lone pair will be considered. We can infer this from here. So let's say I have another example. Last one for today. I think I should give this as a homework. Think about it. What will be it? Think about this one and this one, so that you put your effort into understanding these two compounds, A and B. Think about the possibility, what makes you feel that this is aromatic and this is non-aromatic, or this is non-aromatic or anti-aromatic, and think about the possible reason, and then we'll discuss this in the next class. We'll start off with this. Okay?
Okay.
Yes, ma'am.
Fine. So this will be your homework, and whatever the compounds I have given, that is the pool of compound. And if at all you guys encounter any new compound while practicing, get it to me. Okay? So we'll stop here for today.